Welcome to the project demonstration of food step power generation system along with the utilization of the particular generated power two different ways. So one is AC load. We're going to control this bulb and as well as mobile phone charging to the DC outputs as well as DC street lights. So these are the three outputs powered by this battery, and we are using a rechargeable battery of 12 volts 2 amps. So as you can see this, there are two battery packs. So each battery pack consists of one 4 volt 1 amp and here the three 4 volt 1 amp batteries connected in series, so that each battery pack will provide us the 12 volt 1 amp, and these two are connected in parallel so that we will get the 12 volt 2 amp. So there's 24 watts of power. That particular 20 watts of power will be given as main input to these three outputs. So we can charge an Android mobile phone, which is a micro USB, as well as the AC bulb through this inverter and DC street lights. And here the DC street lights will be controlled based on the light intensity. So that will be achieved by the LDR sensor. Whenever the LDR sensor will detect the darkness on the surface of this LDR, and then particular signal will be read by this LM358 micro is comparator. So LM358 is a comparator which will compare the reference voltage from this potentiometer, that is the darkness sensitivity, and we said that already through this potentiometer, and based on this comparing these two values, particular LM358 comparator will switch on this 5 volt operated relay, this electromagnetic relay. So particular electromagnetic relay will allow the power supply from this 12 volts battery to this street lights whenever the darkness is detected. And particular 705 regulator is provided to get the constant 5 volts power supply, which is sufficient to charge a mobile phone. And coming to this inverter, there are the 50 Hz pulse generated defaultly from this RLC oscillator, and that particular 12 volts AC signal will be step up to the 230 volts AC after this transformer, step up transformer. So then the AC load will be get switched on, and here main power sources to charge this battery. So one is platform, which is consist of 16 piezo plates. So here we can see the underneath, right? So there we can observe the 16, this 4x4 matrix of piezo plates are connected in series and parallel, so that the generated voltage will be given as main input to this battery through this charging circuitry. So here we need to connect the F to the F. So whenever the so-called pedestrians walking through this platform, on this platform, then the generated voltage will be given as input to this battery. So if you want to charge a battery from the transformer, just connect the T to the T section and then switch on the power supply. Then there will be indication of red light. It will take 8 to 10 hours to be fully charged. So once that so-called time is completed, you can disconnect that, and you can, while demonstrating, just connect this here. And here the two switches. One is switches is for the AC load. So it will be on and off, and one more switch is to control this mobile phone charging section as well as the street lighting. So when we switch on this, right, it's on position, and when the darkness is detected, then particular lights will be on. So that we can place, right, when we cover up the LDR, then automatically these two street lights will be on, and when the light is detected, it will be off. So in this way we are going to utilize the so-called power is generated from the food step. As we are demonstrating this, we have used the 16 piezo plates. Whenever the same force is applied on the each and every piezo plate, then the particular voltage will be given as input source voltage to this battery as well as transformer. So coming to this LM358 comparator, so as we discussed initially, so it will compare the two values, its reference values and the LDR output voltage, and based on that signal it will give the inputs to the trigger pulse of our relay circuitry. And after this 7805 regulator, we will get the constant 5 volts power supply. Thank you.